In the 1950s, humanity was producing about 2 million tons of plastic each year. This number has now climbed up to over 450 million tons. Estimates show that life science-based laboratories alone create 5.5 million tons of plastic waste annually across the globe. Being the whistleblower on the impact of plastics on climate change, the scientific community must lead the transition to more sustainable practices. A lot of the plastic material consumed by laboratories is single-use plastic equipment, including pipette tips, microcentrifuge tubes, petri dishes, and other similar products. This kind of plastic equipment is often used in labs because it is less costly than other alternatives and easily disposed of while limiting contamination risks. However, lab equipment cannot be recycled if it has been in contact with DNA, RNA, cells, proteins, or toxic chemicals, which forces this plastic to be sent to landfills if it is not incinerated. Also, only 9% of plastics are actually recycled in Canada, which reduces the benefits of sending away the portion of equipment that could be recycled to a recycling facility. Laboratories are usually aware of the amount of waste they produce, and some universities have turned to companies that actively try to reduce the waste generated by the plastic packaging of equipment. Certain labs have reverted to more traditional techniques, such as using metal inoculation loops, but it has been stated that those techniques are time-consuming, create efficiency problems, and are less convenient overall. Bioplastics can be a promising solution to this problem in certain cases. Bioplastics are plastics that are bio-based or made from renewable resources which can be biodegraded. Their monomers, these small construction blocks forming polymers, are extracted or synthesized from biomass compounds like plant sugars to become a substitute to existing plastics, such as polyethylene. Bio-based plastics have a better carbon footprint than fossil-based plastics. In fact, each metric ton of bioplastics produced generates a bit over 0.8 metric tons of carbon dioxide equivalent emissions, as opposed to 2.4 metric tons of emissions per metric ton of traditional plastics. Bioplastics have advantageous material properties. For instance, polyhydroxyalkanoates, one of the most known kinds of bioplastics, are resistant to water and moisture and can tolerate a high range of temperatures depending on their application. Other promising bioplastics include polylactic acid, polyamide 11, and multiple cellulose, starch, protein, and lipid-based biopolymers. Bioplastics are said to have an impressive biocompatibility and biodegradability, so they can be used in a wide array of products, including packaging and scientific equipment. Bioplastics are most often synthesized from plant waste, which first goes through a pretreatment to obtain the monomers. Then, the resulting substrate can go through an accumulation, fermentation, acidification, alkalification, or heat treatment process to obtain the wanted polymers. Further processing takes place to extract these polymers. Finally, plasticizers and additives are added to create the bioplastic material. Bioplastic objects can then be made using plastic injection molding. It currently costs around $7 billion to supply all laboratories around the world with single-use plastic equipment. If all laboratories were to simultaneously switch to bio-based plastics, it would cost an additional $13 billion. Even though bioplastics are for now more expensive than regular plastics, the projected increase in demand for these new materials, combined with a higher crude oil price, would reduce the cost of production and supply. Partnerships could be established between laboratories and companies to make those product options more accessible, and, with growing experience in bioplastic production, the process will become more efficient and reduce in cost as a consequence. Depending on the way they are made and how they are disposed of, bioplastics have the potential to have a very high ecotoxicity. When these materials are made from agricultural waste, they can contain traces of pesticides and other chemicals, increasing their risks to the population. Laws around what bioplastic components can legally be mass-produced need to be constantly updated to encourage the arrival of newer and less environmentally damaging biocompounds. Since bioplastics replace petroleum plastic but do not completely eliminate the use of single-use items, they do not create a rapid or drastic change in people's habits. Though, educating the population and shifting their perspective around plastics could make people refuse them altogether and end up changing social norms and culture. In this way, bioplastics are one small step towards a completely plastic-free world.